Discrete Mathematics, Modeling Our World, is the fourth edition of a text that has been used in hundreds of high schools over the last 25 years. Its roots can be traced to a report on discrete mathematics issued by the National Council of Teachers of Mathematics, NCTM. That report included an outline for a high school course that guided the writing of a preliminary edition that was tested in high school classrooms and in professional development workshops. Feedback from this testing was incorporated into the first edition. The authors were high school teachers at the time and also leaders of discrete mathematics institutes. They partnered with COMAP to develop the kind of discrete math text they felt was suitable for high school students. They wanted a book that was written informally and at a level that high school students could read. They wanted an engaging book that promoted active learning. They wanted a book that could be used with average students, but also provided challenges for the best students. The major topics in this book are those that were outlined in the NCTM Discrete Math Report, with the exception of Codes, Chapter 9, which is new to the fourth edition. Chapter 10, which is also new to the fourth edition, includes a brief treatment of logic, including truth tables, set notation, including Venn diagrams, bin packing, and linear programming. This correlation shows how the book's content matches the current DODEA discrete math standards. This document is provided for your reference in planning and teaching the course. These 6 strands flow throughout the book. All are important to the way in which discrete mathematics is used in the world, and all are treated contextually. Students' understanding and mastery of these topics develop over time, often slowly. We advise being patient, encouraging, and guiding. These supplements accompany the text. We strongly recommend reading the teacher notes as you teach the course, especially the first time. The masters, software, and videos are referenced in the teacher notes, with suggestions for their use when appropriate. A supplemental data analysis chapter is available on request. COMAP includes it because at least one state, North Carolina, has this content in their discrete math standards. There are about 350 test questions, approximately 35 per chapter, that can be used to construct chapter tests and quizzes. Most are multi-part. They assess students' understanding of basic concepts, but also ask them to justify their conclusions and apply their knowledge in new ways. Projects and explorations occur at the end of most lessons and provide opportunities to challenge better students and to develop communication skills via written and oral reports. Each chapter has a set of review questions at the chapter's end. In every chapter, the first review question asks for a written summary of what the student thinks are the chapter's big ideas. Each lesson's teacher notes include suggestions for assessing progress in that lesson. Note that the student text includes brief answers to key exercises so that students can assess their own progress. These answers are usually not as extensive as their counterparts in the teacher materials. The book's table of contents is a good place to get a quick summary of the content. Chapter 1 is fairly typical in that it has 5 lessons, sections, an extension, and a review. The chapter extension in each chapter is a brief reading on a topic closely related to the chapter's content. It can be a launching point for student research and reporting. At the very end of each chapter is a bibliography that can be used to research the chapter's content, including the material in the chapter extension. Now let's take a look at the first lesson of Chapter 1 and the related teacher notes. Each chapter's teacher notes begins with lists of materials needed or recommended, related videos, software, both included, and modules, related internet sites, masters that can be used for slides and handouts, included. These lists are followed by chapter objectives and a brief summary of the chapter. The first page of each chapter is a brief introductory reading that includes key questions that drive the chapter and states the chapter's purpose. In this case, the reading begins to build two of the book's strands, modeling and decision-making. The first lesson of Chapter 1 is an exploratory activity. The activity is intended to familiarize students with the chapter's main concerns and to give students an opportunity to actually invent some of the chapter's mathematics themselves. One of the appealing aspects of many topics in discrete mathematics is that they do not require years of preparation in order to tackle significant problems productively. Note that the second page of this activity has the first of this book's many news clips. These clips have been chosen because they are related to the content and because they add to the contemporary, real-world feel of the book. In some cases, the text refers directly to a clip. In others, the clips can be used to provoke a class discussion. The teacher notes that accompany each lesson begin with a brief statement of purpose, followed by a bulleted list of teaching tips. The authors know that high school teachers are busy, and so have tried to keep these notes brief and succinct. They include sage advice based on the author's experience using the book with students, as well as with other teachers. They are worth reading, especially when using the book the first time. Note that in this case, the notes recommend doing the activity in groups and using the results to reinforce student ownership of the content. Also note the references to masters, fourth bullet, and software, third and fourth bullets of page 4. A lesson's notes usually end with one or more assessment suggestions, as seen here in the final bullet before the exercise comments. The purpose of many of the exercises is fairly obvious, but the exercise comments point out areas of special concern and provide suggestions for dealing with common student errors. The authors intend that students will do most of the exercises, not just the odds or the evens. Exercises in this book can have several purposes. Perhaps the most obvious are to reinforce student understanding and provide practice. But the exercises can also challenge students to go further than they did in an activity or in reading a lesson's text. Note that exercises 9 and 10 introduce new ideas. Also note that when a new term is introduced, it is defined informally, bolded, and highlighted in yellow. Exercises that develop new ideas are common in this book and demonstrate the author's commitment to engaging students in their own learning. Developmental exercises include immediate practice via the questions that follow and reinforcement via selected answers in the back of the book. Exercise 12 introduces another of the book's themes, recursive thinking. Although recursive thinking is a natural idea, what comes next, students often find a mathematical approach confusing. The authors believe that the difficulty often arises because of mathematical symbolism, subscripted variables. Thus, they have embedded practice with recursive thinking and symbolism where the opportunity arises in the first 7 chapters in order to pave the way for Chapter 8's formal approach. These first 2 pages of Lesson 1.2 show that this lesson begins with the reading rather than an activity. Page 8 also shows 3 common features: mathematician of note, technology note, and the practice of using red to highlight something of significance, in this case, the calculation that produces the highest point total. Technology notes are one way of reinforcing another of the book's themes. It is worth mentioning here that the book provides guidance on the use of technology, such as graphing calculators and spreadsheets, but does not always make the decision on when to use technology for the students. That is something that they should learn to do for themselves.